What I'm showing here is the Arduino CNC Shield sitting on top of an Arduino that it was made for. And this video is to talk about this Black Pill and replacing the Arduino with this Black Pill and interfacing it to the CNC Shield. The only question at this point for any of you is, why would anybody want to do that? Well, let's talk about it. I compiled this sketch using the Arduino IDE, and you can see in the tools pull down underneath the blue line that it's set up for the Arduino Uno board. Now, in this sketch, you'll see that on the right side of the first line, you'll see the maximum bytes available for flash is 32K, and that 39% of them are being used, so there's plenty of room there. On the other hand, if you look at the far right of the second line, you'll see that the RAM is only available, only has 2K of RAM available, and this particular program used 76%, leaving 477 bytes. Now, the worrisome thing here is that we get a warning message that we have low memory available, and stability problems may occur. Now, if I compare the Arduino Uno with the two varieties of the Black Pill, the STM32F401 and F411, I can see right off the bat that the clock speed is a lot faster with the F401 or F411, which, however, using stepper motors, the clock speed is, for the Uno is fine as it is. Now, if I want to start writing big programs, I may have some problems with a 32K flash versus the capability of using 256K for the F401 or 512K for the F411. Now, my problem in the program that I compiled, that I just showed you, was that I only had 2K available for variables in the Arduino. So if I was saving a lot of data in the Arduino, I could be beyond the 2K, or need more than the 2K RAM that I have available on the Arduino. So having 64K available on the F401 Black Pill or 128K available on the F411 could get me a lot further, especially if I was starting to program some AI functions, because they require a lot more storage. Okay, I've compiled the same sketch with the F401 as the board. And you'll see that the first line shows that I've got the 256 kilobytes, and the first line of the screen below it for the F411 shows that I have the 512 kilobytes. On the second line, you'll notice for the F401 that's used 5% of the global area, and it's got 61,980 bytes left rather than the 477, and it shows that it's a 64K RAM at the end of the second line. On the bottom screen where I compiled the F411, you'll notice that the dynamic memory, it's only used 2%, and I've got 127,516 bytes instead of the 477 on the Arduino, and it shows that the RAM is 128 kilobytes. Well, I've made up this chart just to give you an idea of how some of these pins are going to be used. Now, on the left side over here, you see that this represents the pins on the CNC itself and the pins on the Arduino on the left side of the modules. So you can get the exactly what the pins represent by looking at the Arduino itself. And the data for the CNC, I got from the back of the CNC. There is some information there, and also some pinouts on Google. On the right side, of course, is again the pins on the that the CNC is plugged into, and then the description of the pins on the CNC itself. Now, if you were going to simply wire the drivers that fit on top of here, if you were going to wire these in, you would need 2 wires for the stepper motors themselves. You would need 2 wires for the power. You would need 2 wires for the drivers themselves, because they're at 5 volts and the motors are at a higher volt. Then you would need 4 pins here to connect the motors. If you're using the CNC, the 4 pins for the motors are right here. These are the 4 pins, so you don't really need to wire to the driver itself. On the other side, you do need the direction and the number of steps you're going to take, and that's information that does come from the processor, from the Arduino in this case. Then you have 2 pins here that you use to enable this device, and you have 3 pins here that tell you whether you're going to use full step, half step, quarter step, and so on. And then there's an enable. Okay, so, but however, if you're going to be putting these on the CNC, and then looking at how you can replace this Arduino, the only things you really need is you need the power. Instead of having 2 pins on each of the 4 drivers, the power for the motor is just right here, and then the PCB board itself has all the connections made for you. Also, and to enable each of these, you just enable it here with this jumper. And then if you're going to use this 4th driver for 4 motors, then you need to connect these 2 pins together, actually 2 pins here and 2 pins here, and it specifies that that corresponds to 13 and 12 on the Arduino, and 12 and 13 on the Arduino. So the step, the number of steps and the direction for this particular driver is dependent on these 2 jumpers here. So when you come right down to it, the only thing, oh, one other thing is that if you're going to wire in the driver itself, remember there's 3 pins there that you would specify to determine whether you're going half step. Well, here you just simply put a jumper on here. So if I was going to use quarter steps, I could just put a jumper across these 2 pins here, and on all 4 of these. Now, that says, the voltage for the drivers comes right from the Arduino, and it uses the 5 volts and uses ground. So the only pins that you really need to be concerned about are the number of steps and the direction. And since these 2 jumpers make this the direction, and in this case, this is the number of steps for the 4th driver. It's called A, where the other ones, X, Y, and Z, are really set up for right here, the direction and the number of steps, direction, number of steps, direction, number of steps. So that takes care of the 4 drivers. The only other thing that that you would normally do if you were using the CNC on top of the Arduino is you would put in the limit switches. Now the limit switch is just an on-off. So in your code, you're looking to see whether or not the limit switch is set to a high or 1 or low or 0. And basically, when you plug the limit switch into the appropriate pins here, it simply goes down to the Arduino itself, and you're looking at the pins on the Arduino. So if you were going to take the same pins that the Arduino looks at and take those pins and wire them to another processor, you can simply just wire, instead of doing that, instead of plugging this into one of these pins here, you could just plug it right into the other processor. Like if you could get to the Arduino with this board being in the way, you could have actually just connected this this limit switch right to the pins and check it in the code like you would normally do using the CNC. Okay, so that gives you a little background of where I'm going. This is what the CNC Shield looks like, interface to a STM32F4 Black Pill. I want to show you how it is wired, but before I do that, I'd like to show you what it would look like if you did not have the shield, if you try to wire the Black Pill itself directly to the stepper drivers. This is an example of a Black Pill being connected directly to the drivers. This prototype was actually part of my previous video. In case you want to know more about how this thing actually works or see an example of it, I've got the title on the bottom of the screen. Now, to start with, on the wiring of this, the bottom base here is set for 12 volts when it's being used, and the 12 volts are required for the stepper motors themselves, and they use these 2 pins, and there's a capacitor here to prevent spikes. So these 2 pins would be for this driver, and so on, driver for this driver, and for this driver. The next 4 pins would be used for the motor itself, and you would put the stepper motor in here, there, over here, or over here. The last 2 pins on this side are the voltage itself, 5 volts, for the driver itself to process and communicate to the Black Pill. The 5 volts that I have set up here is accomplished by taking the 12 volts here through this converter and converts it to 5 volts, which is on this bank as well as this bank. On the other side, you'll see the first 2 pins are the most important pins as far as the interface to the Black Pill, because that's the determines the rotation of the stepper as well as the number of steps it's going to go. And you have that here, 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 and here. The next 2 pins that you see, little orange thing, is connecting the reset with the sleep to make this an active driver. And this green wire here is connected to voltage. These 3 pins are M1, M2, and M3. And the middle one, if you have that on high, it'll make the driver work as in quarter step. If you had it over here, it would be half step. If you didn't have it at all, it'd be full step. This last pin is something I can't do with the Shield. What it does is if I have it on high, it deactivates the driver, and if it's on low, the driver is active. The other information, this is only used when you're loading the Black Pill with a code from the host using this USB to serial interface. And this is an I2C communication that I was using in the previous video. So that's how it would be wired. The Black Pill would be wired to use the drivers themselves. I just want to tell you about one small problem when you're using the Arduino CNC Shield on a breadboard. The pins on the Shield itself have to match the Arduino because they fit right in there. And if you notice on the Arduino, the 6 pins here are separated by one little opening that's the size of a pin. But over here, it's much smaller than a pin, and therefore it does not lend itself to a breadboard as easily. To show you what I mean is if you take the 6 side and you try to fit it into the breadboard, you see it fits very nicely. But however, if you go on the other side and you put it into a breadboard, you'll see that the second row of 8 is skewed over because this spacing is not set up for a breadboard. It's set up for the Arduino. Now, the way I got around that problem was that I got some long female headers, and I put them on the board. Let me get these on here. And of course, if you have them on one side, you have to put them on the other side so the thing is even. And the length of the long headers allows you to have a little leeway as far as bending them. So, of course, you're going to line them up too. And that one, I didn't realize it's going to be a little bit skewed. Well, I can tell you that I'm not doing well on that. Okay, that side looks like it's in. Okay, that's the good side. Now over here, where you have a little problem with the pins not fitting, you can maneuver them a lot easier. Now you can certainly bend the original pins on the but it's much easier with these longer pins, you see. So I've got those in there now. Okay, so you do see that they're there. So you can use this for a breadboard. Okay. Okay, now I want to talk about the Shield. And I have these 4 stepper motors, X, Y, Z, and A, plugged into the spots for X, Y, Z, and A. And then, again, this is going to be used for the motor voltage, which I'm using 12, even though it can go from up to 36 volts. Notice that I only need 2 wires to go for the motor voltage. I don't the PCB itself distributes that to each of the drivers. So I eliminate all the having to do all that wiring. Also, the 5 volts and ground that would normally be in this position if you were looking at the Arduino only goes to a 1 5-volt bus here that, and of course the PCB distributes it also. The other thing is that we don't have an enable wire for each of these. This enables the whole board. Of course, you don't need the USB to serial adapter here to load the code once the code's there. So during the demo, I'm going to just remove this. During the load of code, when you're not using the shield, it does pick up the voltage here, and it picks up the ground here from this adapter. The power for the Black Pill comes from this strip also. In the demo, I'm going to show you this this little voltmeter to show that we have 5 volts coming here, and then I show also the 12 volts is on this strip here. The actual data lines that show the rotation or direction of the motor, as well as the number of steps is set up. And these positions here were shown on the chart that I pulled up to show you what the CNC fields would be, and then they're associated to this Black Pill, and these addresses will be in the code that I show you after I show you a demo of the motors working with this. I think. Oh, the other thing is that I had mentioned to you that the limit switch did not have to be plugged into the shield itself. It could just go to any field that you wanted to on the Black Pill, and then of course you have to use the pin on the Black Pill or to reference whether or not the switch is on or off. Okay, now this is a demo to show that the Black Pill can interface with the shield and process the 4 stepper motors. One thing I wanted to show you was that the F411 that I'm holding in my hand looks just like the F401 that's on the board. I have so many more of the 401s than I do of the 411s that I put this little white dot here so that I could tell the difference without looking at it. But of course, the chip has it on there, but it's hard to read. One thing I did notice on the 411 that I have, I'm not sure it's that way with all, but the 4 holes here for pins are a little brass color, where the 401 has sort of a silver color. So that might be a characteristic difference between them for all of them, but it certainly is for this one. Now for the demo, right now, I'm going to show you the code that's doing this, but I'm using this one limit switch for all 4 of these motors. And what I do is I press down on this for a little bit, and it'll reverse its motion. So right now it's going clockwise, then it'll go counterclock. And when I press it again, then the next one will start, and this one will stop, and it'll go clockwise and then counterclockwise and so on, and then it'll come back. So I'm going to just do that. I'm going to hold this down just a bit. See, it turns around, and now I'm going to hold it down again, and it'll go to the Y. Okay, so now the Y stepper's going, and I'm going to hold it down again, and it reverses. Okay, then I'm going to hold it down again, and the Z starts, and hold it down again, and it reverses, and hold it down again, the A starts, and I held it down too long, so it reversed. Now I hold it down again, and the X starts again, and it'll just keep going like that. So that is a demo showing that I can actually control the 4 stepper motors from the Shield using the STM32F. In this case, it's the 401, and it does what it's supposed to do. But now I'm going to show you the code to show you what is working right now. Okay, now I'm going to be looking at the code. We include the sales stepper .h library. I define the limit switch to the pin PA8 on the black pill. I have 2 constants I'm using here to delay the loop a little so that I can get from one of the stepper motors to the other. I define the 4 stepper motors with the pins on the black pill, and so that's X, Y, Z, and A. And then in the setup, the only thing I have to do is identify the pin that I'm using for the limit switch as input, and then I initialize the 2 variables I'm using. Now in the loop, this is sort of, you may have a problem with this, but this is the check for the switch. But within the switch, if I can't hold it down just for a cycle or 2 that it will go through. It'll go through this loop many times by the time I'm holding down the switch. So what I do is I delay the actual use of the switch by 500,000, which gives me enough time to hold it down just a little bit. And then what I'm really doing is I'm incrementing an index from 1 to 8 so that I can go through the 4 stepper motors going clockwise and then going counterclockwise. Okay, so this is going to establish a switch case index of I going from 1 to 8. So now looking at the switch case index for case 1, I've got the X stepper motor going. In this case, this is clockwise, and then if I touch the limit switch, and then I go to I go to 2 on the index, and I go counterclockwise, which is just these values minus. Okay, and then I do the same thing for the Y. I go clockwise and then counterclockwise, and for the Z, clockwise and counterclockwise, and A, clockwise and counterclockwise. And that's the code that I was showing you in the demo. It's not very complex, very simple code, and then you could do whatever you want. Notice this is the exact same code that would run in a Arduino Uno. As a matter of fact, to run the Uno, you would come down here and look at the board, and you would come over here and just select the Uno and then the port that you're using. In this case, I'm using the 401, and if I wanted to use the 411, I would have selected this one. Okay, now, when I compiled this, notice that I did get the 64K for the RAM, and if I need any more justification, I can come down here, and it gives you the device name, which is the STM32F4 Okay, well, I've showed you everything I could show you, and then the demo and the code, and this is it. So if you have any questions, please put them in the comments, and otherwise, thanks for watching.